Hello dear students, today we are going to see a new chapter, Unit 6, which is three-dimensional geometry and vector in space, which is designed for natural science students only. So in this chapter we are going to see coordinate axes and coordinate planes in space, and then we'll try to see how to locate a point in space, the coordinate of a point in space, and then we'll try to find the distance between 2 points in space, distance between 2 pointers. And next to that, we'll try to find the midpoint of a line segment in space, and equation of a sphere also included in this content. Finally, we'll try to see vectors in space. So let's see each one by one. Now, coordinate axes and coordinate planes in space. Students in lower grade, you have learned about Cartesian coordinate plane. Simply it is x-axis and y-axis, x-axis and y-axis. In this chapter, we'll see this coordinate, not coordinate plane, this coordinate axis in space. We'll see in space. To make this coordinate axis in space, we need another axis, z-axis. So the axis in space are, the first one is x-axis, y-axis, and z-axis. So these axes are just drawn like this. Most of the time, we put x and y axis on horizontal plane. So this is x axis, this one y axis, and we have here z axis, additional axis. We have this one. So these three axes are mutually perpendicular. And let's try to visualize this coordinates plane. This coordinate plane. One plane you can see here, this one, the plane, this plane. So please just, you can imagine in your home, this floor to be it's xy plane, and we have another plane here, it is zy plane, one of the wall of your room, and the other plane here. So this is the coordinate plane in space. We have this xy plane, zy plane, and xz planes. So next to this, we'll try to locate points on this plane, on this space. So let's see example. Let's try to locate this point 2, 4, 3 on this space. To locate this point, I need to division on y, x, and z axes. So let's divide the value of y. Look, this one. We need 4. So 1, 2, 3, 4, 5. And z on the axis. Let's divide this one. 1, 2, 3. On x-axis, let's divide it. 1, 2, 3, and so on. So to locate this point, let's first draw a line which is passing through. The x coordinate is 2, so the x coordinate is here. Draw a line parallel to y-axis. It must be parallel to this one. And next, draw the y coordinate is 4. Draw a line passing through 4 parallel to x-axis. So you will have the intersection here, and then just you lift this point to up to the height or up to the value of z, which the value of z is 3, or you may draw like this. Look, this one, just draw from this point parallel to z axis and equal magnitude to 3. From this, draw parallel to x axis. So just try to fill a box. Next to that, draw a line parallel to this one with equal in length to this one. So draw horizontal line here. This point is the coordinate of A. This point is A with coordinates it is 2, 4, 3. So this is how to locate a point in space. So please students, try to locate so many points in space. There are a lot of questions in your text. So for now it will be enough. So try to do by yourself. Now let's proceed to the other part. Now the next section is distance between two points in space. Distance between 2 points in space. By the way, in lower grade, you have learned the distance between 2 points in a plane. So in a plane, we have two coordinates only, x and y, x1, y1, and x2, y2. To find the length of this, simply just I think you know how this is derived using a Pythagoras theorem. So the distance will be this. It's the difference between the two. It is x2 minus x1 squared, x2 minus x1 squared, plus y2 minus y2 minus y1 squared. With the same procedure, the distance between 2 points in space A and B is evaluated using this equation. So simply, it is a distance between the 2 points A and B, assume it is some length AB. This equal to the square root of the difference of the two squared, x coordinate, the difference between y coordinate square, and the difference between z coordinate square. So using this, you can evaluate the distance between 2 points in space. Now let's see example. Let's try to find the distance between these 2 points, E and F. So this distance will be, it is the square root of the difference between x coordinate 4 minus 1. It becomes plus 4 plus 1 squared plus 0 minus 3, that's plus 0 plus 3 squared, plus negative 2 minus 6 squared. So when you square this 25, the square of this is 9. The square of this 1 minus 2 minus 6 is minus 8. Its square is 64. Therefore, when you add this, you will have this 1. Therefore, the distance between these 2 points as it is the square root of 98 units. Now, let's continue to the other section. Midpoint of a line segment in space. The midpoint of a line segment in space. I think you can remember the midpoint formula especially you have learned this in grade 10, in a plane. If you have a point here, this point, assume the coordinate of this point is x1, y1. And this end point to be is x2, y2. So the midpoint of this line segment, the coordinate of the midpoint of this line segment is evaluated as by taking simply the average of each coordinate, the average of x and y. So that means the average of this one is you take x1, x2, x1 plus x2 over 2 and y1 plus y2 over 2. So in the same analogy, we can find the midpoint, the coordinate of midpoints in space using this equation. If we have 2 points in space, A and B, x1, y1, z1, and x2, y2, z2, to find the midpoint coordinate, we apply this formula. Simply take the average. Simply it is x1 plus x2 over 2, y1 plus y2 over 2, z1 plus z2 over 2. So this is simple. Now for this, let's see one example. Let's try to find the coordinate of the midpoint of the line segment AB, where the coordinate of A is this 1 and B is, it is 1, 5, 7. Applying the formula, we'll have this one. Simply take the average. -1 plus 1 over 2, 3 plus 5 over 2, -3 plus 7 over 2. So this one is 0 over 2, that's 0. This one is 8 over 2, it is 4. This one is 4 over 2, that is 2. So the midpoint, the coordinate of the midpoint of this line segment is this one. Now, next to this, let's see the other section, 6.5, equation of a sphere. Equation of a sphere. Okay, to write the equation of sphere, let's start from equation of circle, just you have learned in grade 11. If you remember what a circle is simply it's a set of points in a plane that are at equal distance from a fixed point. So I think you remember this. This is a circle. It is a set of points in a plane that are at equal distance from a fixed point. We call it center, and the fixed distance radius. So to write the equation of this, I think you remember this one. You take an arbitrary point, assume the coordinate of this will be this h comma k. So the equation of this circle will be this. The distance from center to any point, any arbitrary point on a circle is fixed. Therefore, using that, we'll have this one. X minus h, the whole squared, plus y minus k, the whole squared is equal to, that is the radius if you take under squared, or you can write this as square. So I think you remember this. So using this concept, we can extend to the sphere. So a sphere is a set of points in space, not on a plane. It's in space that are at equal distance from a fixed point called center of the sphere. So now let's try to write the equation. We have this one. Assume this is sphere. This is radius. So to write the equation of this sphere, simply take any arbitrary point, x, y, z on the sphere. Assume the center of this sphere to be ABC. So the distance between the center to any arbitrary point on the sphere is this radius. So using this concept, you can write the equation. The distance between these two is this x minus a the whole squared plus y minus b the whole squared plus z minus c the whole squared is equal to, you put under square root, or you can write this as a square. So this is the equation of a sphere. This is the equation of the sphere. So you'll have this one. Therefore, the equation of a sphere whose center ABC and radius r is given by x minus a whole squared plus x minus b whole squared plus x minus whole squared is equal to r squared. So let's see example for this one. Try to write the equation of a sphere whose center is 1, 2, 3 and radius is this 4 unit. So to write the equation, simply you can apply the formula. So applying the formula, simply x minus 1 the whole squared plus this one is not x, it is y minus 2 the whole squared plus this one it is z minus 3 the whole squared is equal to 4 square. Therefore, Therefore, here we will have x minus 1 the whole squared plus this one is y minus the whole squared plus z minus 3 the whole squared is equals to 16. So this will be the equation of the sphere. Now let's add more example. Now let's see this one. Given this equation, it's the equation of a sphere. It's x squared plus y squared plus z squared minus 6x minus 4y minus 10z is equal to negative 22. So from this equation of a sphere, please try to find the center and the radius of the sphere. Center and radius of the sphere. So to find that, I need to write this in this form: x minus a the whole square, y minus b the whole squared plus z minus the whole squared is equal to r squared in this form. If you write in this form, the center will be simply easily you can find easily from this equation. A, B, C the center, and R will be the radius. So I need to write this in this form. So to write in that form, we need to apply a completing square method. So to apply that, first arrange the variables together: x squared and minus 6x plus y squared with minus 4y, z squared with minus 10z is equal to negative 22. To apply completing square technique, simply you add half of the middle term squared. This is a middle term square minus 6. Half of minus 6 is minus 3. You square it 9. You add 9 here, and the middle term is minus 4 here. So half of minus 4 is 2. 2 square is 4. You add 4 here, and minus 10. Half of minus is 5. You square it 25. You add 25. All things added here must be added on the other side to make the equation balanced or unchanged. So you will have this one. This is x squared minus 6x. You add 9 here. Y squared minus 4y. We add 4 here. Z squared minus 10z. 25. So 9, 4, and 25 are there. Therefore, this one is a perfect square. You can write this x, half of this one, x minus 3 squared. This one, y minus, half of this is 2, y minus 2 squared. This one, half of this is minus 5, z minus 5 squared. So you'll have this one. Therefore, this becomes x minus 3 whole squared plus y minus 2 whole squared plus this one, z minus 5 whole squared, is equal to the sum of this is this 16. Therefore, from this, I can write this in this form: x minus 3 squared plus y minus 2 squared plus z minus 5 whole squared is equal to 4 squared. From this, you can easily find the center in the radius. Therefore, the center is opposite of this one. 3, the opposite minus is 3, positive 2, and positive 5, the center. And the radius is this one. It is the square root of this result, or it simply you can take 4. Therefore, the center of this first is 3, 2, and 5. And the radius it is 4. So that's it. Now let's proceed to additional example. Let's see this one. If A is 0, 0 and the coordinate of B is 4, 6, 0, these are the endpoints of the diameter of a sphere. So we are asked to find or write the equation of the sphere. So I think you know, to write the equation of sphere, we need the center and radius. In this case, we are given the endpoints of diameter. So from the endpoint of the diameter, you can find the center by taking the midpoint formula. Therefore, this one 0, 0, 0. The other part 4, 6, 0. Applying the midpoint formula, you can find the center. The coordinate of the center, 4 plus 0 over 2, it is 2. 6 plus 0 over 2, it is 3. 0 plus 0 over 2, it is 0. The center is this 2, 3, 0. And not only this one, we need also radius. So the radius is the distance from center to any point on the sphere. So applying the distance formula, you can find the radius. The radius simply is the square root of the distance from 0, 0 to, let's take this one. This is all coordinates 0, 0, 0 to center. So 2 minus 0 squared, 2 minus 0 squared, plus 3 minus 0 squared, 3 minus 0 squared, plus 0 minus 0 squared is 0. Therefore, 2 squared is 4, 3 squared is 9, 9 plus 4 is 13, the square root of 13. So the radius is square root of 13. Okay, the center is this 2, 3, 0, and the radius applying the distance formula from this to this one, simply 2 minus 0 squared, 3 minus squared, 0 minus 0 squared, you will have the square root of 13, square root of 13. So the equation of the sphere will be simply this x minus 2 the whole squared plus y minus 3 the whole squared plus z minus 0 the whole squared is equal to the square root of 13 square. So this will be this x minus 2 the whole squared plus y minus 3 the whole squared plus z minus 0 the whole squared is equal to 13. So this is the final answer. Now let's proceed to the other part, which is this vectors in space. Vectors in space. So if the initial point, I hope you know a lot about vector, just simply to summarize, you have learned in physics, in mathematics, in geography, and so on. So to summarize the basic point, let's say this one. If the initial point of a vector in space, this vector, assume it's in space, its initial point A is this x1, y1, z1, and it's the terminal point to be, it has x2, y2, z2. So this vector written in coordinate form like this. The vector AB is written in this form. It's the difference between x2 minus x1, y2 minus y1, z2 minus z1. So don't forget this one. If the initial and terminal point of a vector is given, so the vector, when the vector written in a coordinate form, it will have this form, x2 minus x1, comma, y2 minus y1, comma, z2 minus z1. So this is the coordinate vector form of AB. So let's see this one here. AB is written in this form. By the way, most of the time we can write in row vector or column vector form. Even you can write in column vector form, or you can use the unit vectors. You can use unit vector representation. I hope you know the unit vectors along x-axis, along y-axis, and z-axis. If you have this one x, y, z, the unit vector, a vector with magnitude 1 along the direction x, it is I, and the unit vector along the direction of y is it is j, and the unit vector along the direction of z is it is k. Using this unit vector, x2 minus x1 is along x direction, so I can write this in this form. x2 minus x1 is the direction of I, plus, and this one is, it has y2 minus y1 in the direction of j, it's y, and plus this one is z2 minus z1 in the direction of k. So I can write this vector in this form. Now, so we can write in this form. And the next concept, the magnitude of a given vector AB is denoted by this letter. Magnitude of vector AB is denoted by this letter. And simply it is given by the magnitude is the length. So simply you will apply distance formula. You have 2 points, A, B. We need to find this length, the magnitude. So x1, y1, z1 here. Here the coordinate of this is x2, y2, z2. So the length of this vector is its magnitude. So this length you can apply to find this length is distance formula. The distance formula says take the difference of 2 square, take the difference of 2 square it, take the difference of these two, z2 and z1, and scale it, and take that result under square root. So the length or the magnitude of the vector will be evaluated. So you can apply this equation. So the magnitude of AB is the difference of the 2 squared, the difference of 2 squared plus z2 minus z1 squared. So we can use this equation to calculate the magnitude of the given vector. Now, if the coordinate of vector A is given to be, if it is given in this form, A, B, C, by the way, you can write this in this form. A in the I plus B in the J plus C in the K. You can write in that form, or even you can use this. So the coordinate vector of A is represented by its A, B, C, and that of B is this F, G. Then, if you are asked to find the sum of the two vectors, simply you add their corresponding components. So you add A with X component with X component, or X coordinate with X coordinate, Y with Y, Z with Z. For subtraction of the same, therefore, A plus or minus B is this, A plus E. In the I direction, you can apply, you can just put I in the I direction, plus B plus F plus or minus F, and C plus or minus G in the K direction. So simply this is how to add two vectors. Now when you multiply a given vector by scalar, so simply you multiply each corresponding components. So R times A will be this, R times A, the coordinate, X coordinate, R times the Y coordinate, R times the Z coordinate. So you will have this one where R is scalar. Now next to this, the dot product of two vectors. I hope you have learned this in grade 11 mathematics, even in grade 11 physics also. So I hope you remember this. The dot product of these two vectors is defined as it is the product of the magnitude of the two vectors times cosine of theta, where theta is the angle between the two vectors. So now let we have this one. Let vector is represented by this unit vector representation, Ax in the I, Ay in the J, plus Az in the K. And let's have another vector B written in this form, Bx in the I plus By in the J plus Bz in the K. Then the dot product of, we can also have another answer for dot product. You can apply this to find another answer for dot product of these two vectors. Let's apply this. A dot P will be the dot product of the two. So AXI dotted with, you can distribute this dot product. So we can apply dot product. Dot product can be distributed over addition. So Ax in the I dotted with this one, it is Bx in the I plus By in the J plus Bz in the K. So this one is over there. One thing to remember here, I hope you know this, the dot product of I with I dot I. So I dot I, simply you can evaluate using this one, magnitude of I times magnitude of I times the angle between cosine of the angle between the two vectors. It is angle between the two vectors is 0, cos 0. Magnitude of I is 1, 1 times 1, cos 0 is also 1. The product will be it is 1. I dot I is it is 1. Similarly, J dot J is also 1, K dot K is also 1. If you take this one, the dot product of I dot J I dot j. When you just apply dot product for this, it's magnitude of I times magnitude of j cosine of the angle between the two is 90 degrees. They are perpendicular. I, j, k are mutually perpendicular. So it is 90. Cos 90 is 0. So this product will be 0. Therefore, the dot product of I with j, I with k, j with k, and so on is 0. So using this fact, when you just distribute this dot product here, the dot product of the two, ax bx times I dot I. I dot I is 1, so this will be this ax bx. The dot product of the two, it is x by I dot j, it is 0. I dot j 0. The dot product of the two is also it is 0. Now plus, let's distribute this one, ay j dotted with ay j dotted with this one. It is bx in the I plus by in the j plus bz in the k. So when I apply dot here, ay j dot bx I, j dot I becomes 0. When you distribute this one here, ay j dot by j, in this case ay by times j dot j. J dot j is 1, so you'll have here ay by. Ay j dotted with bz k, this becomes 0 because j dot k is 0. Plus, let's distribute this one, az k dotted with bxi plus byj plus bzk. So when you distribute this, the dot product is 0 because k dot I. The dot product of the two is also 0 because this k dot j. The dot product of the two, it is az bz, k dot k is 1, so you'll have this one, az bz. Therefore, if the component of a given two vectors is given, their dot product is easily evaluated by multiplying their corresponding component ax with bx, ay with by, az with bz, and then you add these results. So the formula of the dot product of the two will be this one, ax with bx, ay with by, and az with bz. So now let's see another concept, the angle between two vectors. To find the angle between two vectors, we'll apply this. Let's take the two vectors a and b. So the dot product of the two vectors is given by magnitude of a times magnitude of b cosine of theta. You know this. So to find the angle cos theta, cosine of theta will be equal to this. It is a dot b over the magnitude of a, magnitude of vector b. So using this equation, you can find the angle between the two vectors. So you'll have this one. So I hope it will be enough for today. This is all about today's lesson. So I'll see you in next lecture. Until then, goodbye.